how you spell Pythagorean. Pythagorean. Pythagorean theorem. And you can write it out with words like this. If, actually I was going to say you, but let's say it's. If it is a right triangle, then a squared plus b squared equals c squared. And sometimes it's good to draw a little picture to go along with it. A is one side, B is the other side, and C is always the diagonal that connects them. So one thing to notice is that it only works with right triangles. A right triangle is a triangle that has a 90-degree angle. It makes like the corner of a square, like what they were talking about in the video. It's the only kind of triangle it works with, a right triangle. One thing to point out is in your right triangle, I'm going to draw another one a little bit bigger. There's lots of different ways you could draw it, and you could rotate it, and you can turn it, but you're always going to have this right angle right here. And a right angle means that it's 90 degrees. That it's like the side of the corner of a square. The side opposite it is always the C. The A and the B don't matter so much. They're just called legs. You can swap them around. It's either the longer or the shorter. It doesn't matter so much. But what does matter is that C is opposite the right angle. Okay. So if you look down here, I have a couple different right triangles. I could show you the right angle, like on this one is right here. So that means the C value is over here. Here's this right triangle. It's nice and tall, and the right angle is right there. That means the C is this side over here. And this one's kind of like flipped upside down. Here's the right angle. And so the C value for this one would be over here. Now, let's say we had some measurements. Let's say we knew that this triangle, let's say it was 5 units tall. And the C side, or what's also called the hypotenuse, was 13 units. With the Pythagorean theorem, we can figure out this missing length. If this is 5 and this is 13, then there's only one measurement that bottom can be to make that right triangle. And the way we can find that is by using the theorem. Like I said, the A and the B can be any of the legs that you want it to be. So let's just call let's put the 5 in first. If we take 5 squared and we add it with, this is going to be our B. We don't know what it is, B squared. It has to equal our 13 squared. Then that's the power of the Pythagorean theorem. It helps us find these missing measurements. So now we start to solve. 5 times 5 is 25. I don't know B squared, so we leave it there. And then you could use a calculator for 13 squared, or maybe that's one you have memorized. 169. So today you're going to be using the Pythagorean theorem to find missing lengths. And we're going through solving right now. And then you're going to also use it to prove whether a triangle is a right triangle or not. So now we're just down to one variable. We're into algebra. We just do some inverse operations to get to our answer. Let's subtract 25 from both sides. We get B squared is 144. This means some number times itself is 144. Hopefully you remember what the opposite of a square is, of an exponent of 2 is. You can get rid of this exponent of 2 if you take the square root of both sides. Do you remember doing that with the quadratic formula? You take the square root of both sides, you get b is, what is square root of 144? 12, isn't it? And remember, it could be positive or negative 12. But it doesn't make sense to have a negative in this triangle. So we would just say b is 12. There's your answer. Okay, let's try another one. Let's say in this triangle, we know that this side is 12 and the hypotenuse is 15. Let's find our missing side length. We'll call this x. How do you want to set up the equation? We would just go 12 squared plus x squared is equal to 15 squared. That's going to be 144 plus x squared is 225. And then you subtract 144 from both sides. We're solving for x. We get x squared is 81. So take the square root of both sides to get rid of that exponent. So x is positive 9 or negative 9. You can't have a negative distance on a triangle. That like side wouldn't exist. So it would just be 9. Thanks, Sanvi. All right, I want you to try this last one by yourself, and we'll see if we get the same answer. Now, sometimes the triangles are drawn to scale, and sometimes not. This one's not drawn to scale. We do know it's a right triangle, though. And I'm going to tell you that this side is 36, and this side is 15. Go ahead and see if you can figure out that missing side length. You're going to want to use a calculator today. It's going to make your life a whole lot easier. You want to make sure you set it up the right way. That side you're missing is the hypotenuse. It's the C, because this is the side away from the 90-degree angle. So that means in our formula, in our Pythagorean theorem, it's going to look like this. Hopefully that's how you did it. 36 squared plus 15 squared has to equal C squared. That's a little bit different than the other two we did. So 36 squared is 1296. 15 squared is 225. And if we add them, we have to get C squared. So see, we add those, we get 1521 is c squared. What is the square root of that? Ooh, 39. You take the square root of both sides, you get 39. So see, with the Pythagorean theorem, you can calculate a missing length on a right triangle. If you're going to be building or designing any buildings or houses when you get older, you might use this a lot. Okay, so that's one way we use it. Here's another way. We can figure out, is it a, and instead of writing right triangle, I'm just going to draw the symbol. We can figure out if something is a right triangle just by using the numbers. We're just doing triangles today. Yep, your purpose is to be able to use the Pythagorean theorem. You are going to have a little bit of homework, but I'm going to give you class time to work on it. Hopefully you'll finish. Your homework's going to look like this. One part, you're going to have to find the missing side length, just like we did here. And the other part is going to be figuring out if what we're talking about is a right triangle, because right triangles always follow the theorem. So let's say I said that there was a triangle and it had side lengths of 14, 48, and 50. We need to figure out, is that going to make the right triangle? Well, the way we do that is we plug it into the Pythagorean theorem and we see if it works. The larger number is always the C, always. You'll learn more about that in geometry, but with the way you draw, you make this triangle, that diagonal always ends up being longer than the other sides. So what we're asking then is 14 squared plus 48 squared equal to, and I can draw a question mark over it, is it equal to 50 squared? Does it follow Pythagorean's theorem? So let's see. What I like to do in my calculator is I do all the squares first. I go 14 squared, 48 squared, 50 squared, and then I just add together the pieces that I need to add together. So we get, let me see, I'll do it over here. We get 196 plus 2304. And we want to know, is that equal to 2500? Looks like I kind of ran out of room there. Well, it looks like it might be 2304 plus 196. Yeah. So, yes. Was this the measurements of a right triangle? Yep. And they even talk about it in the video. They found back on that, it was the ancient tablet where there was a whole bunch of these combinations that had been worked out already. They must have used it when they were making whatever it was they were making for building. Okay, let's try, you try this one and we'll see if we get the same answer. Is 16, 30, and 34. Would those measurements produce a right triangle? Go ahead and check it out and find out. So we got 16 squared plus 30 squared. Does it equal 34 squared? I think it doesn't work again. I think it does. Is that what you got? Yep, it's the right triangle. If ever those two sides don't match, then you wouldn't have a right triangle. Okay. So there's one more piece we need to talk about, and then I'm going to give you 10 more from your homework. And that is applying this to something useful. Do you remember in the video they talked a little bit about the pyramids? And there's a theory that maybe they used Pythagorean theorem to help them construct the pyramids. Well, think through this problem with me. And sorry, that image is kind of blurry. So originally, there's a great pyramid of Giza, very famous pyramid. Originally, each face of it, so each side, was a triangle with the dimensions shown. How far was a corner of the base from the pyramid's top? So when you're dealing with one of these, it's best to redraw it in a way that's going to help you. And I know that you can't see some of those numbers, so let me just redraw it down here. They've taken the side of the pyramid, the face, and they broke it into some right triangles, and they want to find out how far away is the corner. So it looks like this. You have one triangle, kind of like that. They say that this is 378 feet. This is 612 feet. And then in the picture, they have the other side, which is the same. 378 feet and 612 feet. It says, how far was the corner of the base from the pyramid's top? So what they're asking about is this side here. How far away is that? So we could just call that, well, that's going to be our C, right? It's the opposite of the 90-degree angle, so it's going to be your longest side. And we can use Pythagorean theorem to help us. If we go 378 squared plus 612 squared, 612 squared, then that has to equal whatever that measurement is, C squared. We're going to deal with some large numbers here. So 378 squared plus 612 squared is 517,428. 517,428. Now, when we take the square root of both sides here, we're going to end up with this tricky situation. It's not going to be a nice, perfect square root. We either have to simplify it, like we did in the homework before, or we can estimate it with a decimal. I think in this case, it'd make most sense just to estimate it maybe, but maybe if you were building this, you'd want an exact answer, so you would simplify instead. What we find is that C is about, so I'm gonna do a little squiggly equals, that's about equal to. Oh, it says round to the nearest foot, so actually it tells us to just use decimal. It's about 719 feet. So that number should be larger than all the other numbers we had. It's larger than 378, it's larger than 612. Yep. So there we go. I want to show you one more, and this is one that people end up using Pythagorean theorem a lot on, is a situation like this. A construction worker is cutting along the diagonal of a rectangular board. We want to know what will the length of the cut be. This happens a lot in construction. You're dealing with materials and you need to get this piece of wood to fit where you want it to fit. The question is always, well, how long is this side going to be? So the tip is to first draw your picture. It looks like this. Something like that. Here's our piece of wood. It's 15 feet long and 8 feet wide. what we want to know is if we do a cut here, how long is that cut going to be? So we have a 90-degree angle. That means we can use the theorem one more time. 15 squared plus 8 squared has to equal our cuts. 15 squared plus 8 squared is 289. And when we take the square root, we find it's going to be 17 feet. There's your answer. Okay, so we talked about solving with Pythagorean theorem. We talked about figuring out if something is a right triangle with Pythagorean theorem, and then we applied it to a couple problems. I want you to practice doing it now on your homework, and we should be able to finish this in class, hopefully. Let me post the link in chat here, and for those of you in person, I'll put it up on the board. And you can either print this out or just copy the problems into your own on your own paper and solve.